In this video, we'll collect some examples of solving these second order equations in all their different forms. So for the first equation, we have y double prime minus 8y prime plus 16y equals 0, which gives a characteristic equation of r squared minus 8r plus 16 equals 0. This is r minus 4 quantity squared, so we are in our repeated root or double root case. Therefore, our general solution, since the root is 4, is y of t is c1 e to the 4t plus c2 times t e to the 4t. For the second example, we have a characteristic equation of r squared plus 2r minus 1 equals 0. If that would be a plus 1, this would factor, but it's a minus 1, so it doesn't. So let's use the quadratic formula here to try to work this out. This has roots at r equals -2 plus or minus the square root of b squared is 4 minus 4ac is a plus 4 over 2 is -2 plus or minus square root of 8 over 2. Root 8 is 2 times root 2. So I get -1 plus or minus root 2 as my solutions. So these are two real and distinct roots. Even though these aren't whole numbers, it still works. I can write my general solution using that, which is y of t is c1 e to the -1 plus root 2 t plus c2 e to the -1 minus root 2 t. Finishes that one. And then we have our last example, which yes, did change from the last clip. Y double prime minus 6y prime plus 13y, which gives us a characteristic equation of r squared minus 6r plus 13 equals 0. This doesn't factor, so let's try the quadratic formula. We will get -b, so 6 plus or minus the square root of b squared is 36 minus 4ac is minus 4 times 13 all over 2. 4 times 13 is 52. 36 minus 32 is -16. This is 6 plus or minus square root of -16 over 2. This says right away we're dealing with complex roots. Root -16 is 4i, so 6 plus or minus 4i over 2, or 3 plus or minus 2i. So with that, we can write a general solution, because all we need to know is the real part and the imaginary part, and then write the general solution as y of t equals c1 e to the 3t cosine of 2t plus c2 e to the 3t sine of 2t. So this gives an example of finding the general solution for each of the three different methods. If you were to want to solve an initial value problem, you could. You just go one step further from here, plug our t0, which is usually 0, into this function and its first derivative, and use that to set up a system of equations in order to solve for the constants you need, c1 and c2, to meet those initial conditions. But in any case, this is how you set all these problems up. They will all be of this sort of form. It'll get one of these three results, and you can go forward to solve initial value problems or answer the questions you want about those solutions based on their general solutions, like you see here.